Alright, in this video we're going to talk about section 6.3, day 2, the eccentricity of an ellipse. So the measure of the ovalness, so how elongated an ellipse is called the eccentricity. So how we're going to measure eccentricity is with the ratio of C to A. So E is equal to C over A. Remember that C is the distance between the center and the focus, and A is going to be the measure from the center to one of the vertices on the major axis. So remember yesterday the major axis was the length, or the length of the major axis was 2A. So half of that from the center to the vertice is going to, or a vertex is going to be just A. Now note that E is going to be between 0 and 1 for every ellipse. So how the eccentricity works is if E is going really close to 0, so as E approaches 0, the ellipse becomes more circular. So if you look on the picture on the left, the foci are really, really close to the center, so that C is going to be a very small distance, and that A is just going to be normal. So if we take a really small number, C, and divide it by A, we're going to get something close to 0, and that looks like it's going to end up being circular. Now, as E approaches 1, then we're going to be more elongated. So on the second picture, you can see that C is almost the size of A. So if we get two things that are relatively close to each other and we divide them, we're going to get a number that's close to 1, and that's going to end up giving us an elongated ellipse. Now you'll notice on the definition of eccentricity, it was 0 to 1, and it was not or equal to. It's greater than 0 or it's less than 1. So what happens when the eccentricity equals 0? That's going to mean that we have 0 divided by a number, which means we have C divided by A, so that'd be 0 divided by A, so C would be 0. Well, if C is 0, that means the distance between the focus and the foci in the center is 0, which means the foci are going to be sitting right on top of the center, which means we're actually going to have a circle. So we're going to say if the eccentricity equals 0, you have a circle. And it's really not that the eccentricity is 0, it's that C is 0. But if C is 0, E is 0. Now, if we think about what happens when E is equal to 1, so if E equals 1, then we know that C over A equals 1, which means C equals A, which means this is going to go all the way out to our vertex, and what we're going to end up with there is a line segment, and that's not very interesting. So we're never actually going to see that. But we will see E being 0, and that's going to give us a circle. So let's look at an example of that right there. So we have to identify x squared plus y squared minus 4x plus 6y minus 3 equals 0 as either an ellipse or a circle. So we're going to tackle this the same way we did in the previous lesson. We're going to move this stuff around so the x's are by the x's, the y's are by the y's. We're going to complete the square a couple times. We're going to put this into standard form. And then we're going to see if the eccentricity is 0 or bigger than 0. So first thing, like I said, let's go ahead and rewrite this so the x's and y's are by each other. And let's go ahead and move that 3 to the other side. Now, we don't have to worry about dividing anything or factoring out any leading coefficients because our leading coefficients here are already 1, so we're in good shape there. So if we take this term here, negative 4 divided by 2, that's negative 2. Square it, we're going to end up at 4. So we're going to put plus 4 here. And we want to add 4 over here as well. 6 divided by 2 is 3. Squared is 9. So we're going to add 9 to each side. Factoring the left side, we're going to get x minus 2 quantity squared plus y plus 3 quantity squared equals let's see, it's going to be 16 on that side. So you can see right now that this is probably going to be a circle because we have x minus h squared plus y minus or plus k squared equals r squared. But we can't be sure because the circle is written as r squared, and an ellipse is written as equals 1. So if we were making this an ellipse, we would divide by 16, and we'd end up at x minus 2 squared plus y plus 3 squared over 16 equals 1. So this looks like it could be an ellipse, but that up there looked like it could be a circle. So the way that we're going to tell is we're just going to figure out what the eccentricity is. So remember that the eccentricity is going to be c over a. And if we remember from the previous lessons, c squared is equal to a squared minus b squared. Well, in this case, this right here is a squared, and this right here is b squared. So c squared is equal to 16 minus 16, so c squared equals 0, c equals 0, so e equals 0 over 4, right? So this is a squared, then a is just going to be 4. So the eccentricity is 0, so we have a circle. Now, the quick way to tell is if a equals b, then we are going to have a circle. And if you think about graphing this thing, you'll kind of see why. So this is going to be centered at 2, negative 3. And remember that the a and b are just how far we're going to go in each direction in order to make my ellipse. So a is going to be 4, b is going to be 4. So I need to go 4 up and down, 4 left and right. So we're going to go 4 that direction, 4 that direction, 4 up, and 4 down. Well, if I went 4 in every direction from the center, then that's going to give me a circle. So if a equals b, then c has to equal 0. If c equals 0, e equals 0. If e equals 0, we have a circle. So again, quick way to know if it's a circle, if a equals b, which also is going to tell us if a squared equals b squared, right, if you square each side, then we're going to have a circle. So we don't actually have to go through and figure out does c equal 0. If a squared equals b squared, or if a equals b, we're going to have a circle. So one more example, and then we'll call it quits on this video. This one is asking us to find the equation of the ellipse with vertices 0 plus or minus 8 and an eccentricity of 3/5. So just a quick sketch of what's going on here. Vertices are on the major axis. So I have a vertex here at 8, a vertex here at negative 8. So if my vertices are going this way, I know the center is going to be halfway between the vertices, so halfway between negative 8 and 8 is going to be 0. So I know I'm going to be oriented vertically. So I know when I find my a and b, the bigger number of the a has to be under the y because I'm oriented vertically. So I know very generally it's going to look like x squared over b squared plus y squared over a squared equals 1, and of course a is bigger than b. Now, thinking about what we know about an ellipse, our major axis has a length of 2a. So if we're thinking about this, the distance from negative 8 to positive 8 is 16, so 2a equals 16. We know a equals 8, which tells us a squared is 64. So we can go ahead and say that x squared over b squared plus y squared over 64 is going to equal 1. Now we just need to figure out b squared. Now we have a relationship that tells us c squared equals a squared minus b squared. The problem is I don't know c squared. So that's where our eccentricity is going to come into play. We know that by definition e is equal to c over a. And I actually made a typo. This should say e equals 1/2. So if e equals c over a and e equals 1/2, we know 1/2 is equal to c over a. We found over here a is 8, so 1/2 equals c over 8, which means c has to be 4. So c squared is 16. So we know 16 equals a squared, which was 64. So we know 16 is going to be equal to 64 minus b squared. Add b squared to this side. Subtract 16 from that side. We get b squared is equal to 48. So we know b squared is 48. So we get x squared over 48 is equal to y squared over 64. Oops, sorry, not equal to, but plus y squared over 64 is equal to 1. So that's going to do it for this video. We will see you in the next one.